Hello, and thank you for joining me today. My name is Steven Spiller, and I am a software engineer on the multiplayer and networking team in Xbox ATG. This talk is intended to give you a better understanding of the services available to you when integrating your multiplayer title into Xbox Live and why you should choose one over the other. I'll be discussing what those services are, why you'll need to use one, and how to interact with them from your title or title service. I'll present a few sample scenarios and provide links to the detailed documentation for the material covered. Let's first take a look at the services available from Xbox Live. These are MPSD and MPA. MPSD is the Multiplayer Session Directory. It was introduced in 2013 for the Xbox One generation as the way to coordinate multiplayer sessions. It does this by means of a shared document where game clients can exchange information. It integrates with the Xbox shell for sending and receiving invites, allowing other players to join a game session, and tracking recent players. MPSD is also tightly coupled with the SmartMatch matchmaking service and provides features such as managed initialization, where QoS metrics can be utilized in the matchmaking process, and sessions that are pre-populated with match-made players. However, many titles don't require the use of a full multiplayer service because they already have their own, and they only need to do what's required for Xbox Live integration. For those titles, this often means having to duplicate a lot of effort in order to maintain that MPSD session along with their own services. So now enter MPA. MPA is the Multiplayer Activity Service. It was introduced in 2020 to make life easier for titles that already have their own services and don't require everything that MPSD offers. Rather than needing to create and maintain MPSD sessions alongside their own, titles only need to make a few service calls and will get the same Xbox shell integrations as if they were using MPSD. Here are the requirements that are driving the need for you to use these services. XR64 says that if you allow other players to join a game session, it must work from the shell or game bar on PC. XR67, titled Maintaining Session State, is really to make sure that the recent players list is kept up to date. And XR124 covers supporting in-game invites. There are, of course, other Xbox Live requirements, such as enforcing privacy and permission settings, but they don't require the use of MPSD or MPA and aren't covered here. Now we'll take a look at how we can satisfy the integration requirements using MPSD and MPA. The intent is to give an overview of the client APIs to use. However, these are simplified examples, and I strongly recommend you look at the full documentation for each topic that are referenced at the end of the presentation. These calls can also be made directly service to service, and I'll be covering that later as well. Now, before we get started on that, I want to make sure you're aware of the overhead needed to use MPSD. The following examples only show the specific calls needed for each requirement. However, there's a lot of support code needed to make those calls. You need to establish handlers to react to events from MPSD, create the sessions that you'll be using, and manage joining players into those sessions. In our simple cross-gen MPSD sample, this is over 1,200 lines of code. You also need to predefine your session templates in Partner Center and publish them to your sandbox before they can be used. All right, to register a joinable game session with MPSD, you'll be setting it as a user's activity by calling XBL multiplayer set activity async with the active session reference. The user must already be a member of the session and in the active state for this to succeed. Values for privacy level and cross-platform settings are specified in the session document itself. We'll see an example of that on the next slide. For MPA, you'll call XBL multiplayer activity set activity async. Since MPA has no knowledge of the multiplayer system being used, all relevant information is passed as parameters. The first is a connection string, which you'll define, that a joining client would use to connect to the game. Next is the privacy level, which determines who can join the session. This can be public, meaning anyone can join, followed, which means only your friends can join, or invite only, meaning that an explicit invite is required to join. Optionally, the maximum number of players and the current number of players can be specified. If an activity is full in that the current is equal to the max, users viewing someone with this activity in the Xbox shell will see the option to join the game disabled. However, the owner of the activity may always send invites. Now, because state can change between sending the invite and a user accepting it, titles are always required to handle the case where an invite can't be completed. Additionally, a group ID can be set to inform MPA that multiple users' activities are part of the same session. And finally, you can specify whether the activity allows cross-platform joins and invites. Now, here's how that looks in code. On the left-hand side, you can see the call to set the user's activity using the aforementioned XBL multiplayer setActivityAsync. It simply needs a session reference that points to the user's active session. Also note that all calls to MPSD, and then these are the APIs prefixed with XBL multiplayer, which isn't to be confused with XBL multiplayer activity, will take this XBL context handle. This is an object that is created per user and is where runtime state is maintained by the API. On the right-hand side is an example of a session template that could be used as an activity session. Here you'll see the properties that are the analogs of the parameters that are passed to MPA, like crossplay and join restriction. When a session is set as a user's activity session, the Xbox shell will query it for these values and set up the UI accordingly. Now here's an example of doing the same thing with MPA. You can see that we create an XBL multiplayer activity info struct and fill it in with our desired values. In this case, the connection string, join restriction, number of players, and a group ID. We then make the call to set the activity in MPA. Next, we'll look at sending invites from within your title. Both MPSD and MPA have two ways to go about doing this. The first is by using the XGameUI version of the API. This is the one that invokes the system UI, also known as TCUI, to allow the user to select whom to invite and then send the invites all into one call. For MPSD, you provide the user and session information, and the shell will query MPSD directly for the information it needs. For MPA, it only needs the user handle to a user that has previously set an MPA activity. Again, the shell will query the information it needs from MPA directly based on the user that's passed in. The second way to send invites is using the non-UI version of the API. These take a list of ZUIDs for the users to invite. It's useful to use this if you have your own game UX for selecting players. Now for MPSD, you'll also provide the session information for the game session being used, and for MPA, the parameters that are needed to connect to the game, and whether or not the invite can be sent to users on different platforms. Please note that XGameUI show multiplayer activity game invite async is only available starting in the March 2022 GDK. Here's the call to use the system UI to send invites for an MPSD session. In addition to the user, you'll need the SCID for your title, the template being used, and the active session name for the game session. There are also two optional parameters. One is an opaque context string that is just passed along with the invite, and the other is an identifier of a custom invite string that's been configured and published in Partner Center. On the right-hand side, you'll see our game template again. In order for invites to be sent for a session, it needs to have the invite protocol property specified with the value of game, as you see bolded on the slide. And now the MPA version. This will bring up the same user selection UI and then send invites to all the users that are selected from the UI using the published activity of the inviting user. The other side of sending invites is receiving them. No matter which service you're using, your title will need to register an invite handler in order to be notified of invites. Now, this differs from the previous generation where you would receive an application activation event. And you may notice this means there's a time delay between starting up the title and when it registers for invites. If there are pending invites when your handler is registered, it will be invoked right away and the invite will not be lost. The invite handler signature is fairly simple, and we'll see that on the next slide. You'll be given the context object pointer that you passed in when you registered the handler and this URI string. The URI protocol will be in the format of ms-xbl- and then either a title ID if it's on console or multiplayer if it's on PC. For MPSD, the URI will be different depending on whether the user accepted an invite or if they joined using the shell UI. In both cases, you'll receive the ZUIDs for both users, a handle to the game session, and for invites, the context string if one was provided. For MPA, the path will always be invite accept, with parameters for the user who sent the invite, the user being invited, and the connection string. In order to support invites on PC, the Microsoft Game Config needs to specify that multiplayer protocol element or it won't work. Here's the call to register for invites, which takes a void pointer for the context object, a function pointer for the handler routine, and an out param to receive a cancellation token. This is an example of a simplified handler for an MPSD invite or join, which simply finds the session handle. A full handler would ideally parse out and verify the ZUIDs as well, since the user that accepts the invite could be different from the intended recipient if multiple users are signed in on the same console. Also note that the order of the arguments should not be assumed. They are not guaranteed to be in the same order as shown here, or more may be added in the future. But since this is a regular URI, you can use your favorite utility code to parse out the values rather than doing it by hand as we've shown here. The final requirement we have is to maintain the recent players list. For MPSD, the players must simply be in the same active session, and the session must specify gameplay true property. And the system will handle all the rest, unless you're using large sessions, which we'll see in a minute. For MPA, the title needs to call XBL multiplayer activity update recent players with a list of XBL multiplayer activity recent player update structures. Now, this structure only has two fields, the ZUID of the user that's been encountered and an encounter type, which is specified by the XBL multiplayer activity encounter type enum. Now, this should be done for each new game session and include encounters for each user playing in the session. Now, as I just mentioned, MPSD has this notion of large sessions, and that's sessions that support more than 100 players. In a large session, there are some different rules, and the way to track encounters is not automatic. We'll see that again in a little bit. Here's how the call to MPA might look. We fill in a player update struct and call the update API. Now, you might notice that this API isn't async like the others, and that's because it just queues the update and then returns. And updates are coalesced and sent in batches to the service in the background for you. Now, optionally, a title can make an async call to flush all the pending invites immediately, and that's shown here, but this isn't the recommended pattern for normal usage. Okay, now that we've gone over those basics, let's take a look at some common multiplayer scenarios and how we would go about using MPA or MPSD to integrate them with Xbox Live. The first scenario is the classic peer-to-peer setup, where there's no centralized server and each client can talk to every other client. In this scenario, we'll assume that one player designates themselves as the host by starting a multiplayer game and then sending invites to the other users. Each client will be making their own calls to MPSD or MPA. We'll start with MPSD, where first the host needs to create and join a gameplay session. They'll set this as their activity and then send invites to other users using that gameplay session reference. When users accept the invite, they'll parse out the invite handle and use that to join the game session. Once joined, they'll also update their activity. Since that gameplay session template has the gameplay true property. Nothing more is needed to update recent players. Similarly, with MPA, the host user starts the game and then sets their activity. Then they send invites to the other users. As users join the game, they will also set their activity. The difference here is now each client will need to make a call to update recent players manually with the encounter information for every other player that's in the game. This will be done as needed when additional users join as well. Now we'll take a look at a dedicated server scenario. In this scenario, clients each connect to a central server, and the server is responsible for updating MPA or MPSD using service-to-service calls. The clients won't make any of these calls themselves apart from setting their own activity. Making calls service-to-service allows you to manage the Xbox Live integration from a central service where all your game data is. However, it does require additional configuration in Partner Center in order to properly authenticate and make calls on behalf of your title and users. I won't be going into the details of that configuration, but instead invite you to use the resources at the end of the presentation to learn how to set that up. When calling service-to-service, there isn't a library available, so you will need to find some sort of REST calling framework in order to form the requests. But the REST API for the services is published in our documentation. Now, if you were to examine the service calls that are made when you make the calls from a client, you'll notice that the service-to-service calls are nearly identical with just a few notable differences. For MPSD, there are additional headers that need to be specified depending on the service call being made. Those are the on behalf of headers shown in the slide. With client-based calls, everything is done in the context of the user making the call, but when calling from a service, that context needs to be included in the request. And since the service can update multiple users in the same call, how users are identified is different. This is done with the me_zuid format that you can see in the slide. Now, here are a few examples of service-to-service calls to update members in an MPSD session. You can see in the URI the same values that would normally have been passed as parameters in the client API. The first block shows a pair of users being added directly to a session in the active state. The second shows adding member reservations. Being able to update multiple users and properties at once is one of the benefits of using these service-to-service calls. Now, calling MPA service-to-service requires the same configuration and authorization as calling MPSD, but the REST API is basically the same as it is when calling from the client. There are no additional headers, but there are a few additional endpoints provided that can be used to update in batches when calling from a service. Here's an example of updating recent players for multiple users at once. The client version of this call would only take a single object, but here we can update all of our users in one place. When updating encounters with the batch call, MPA will also automatically update all users specified so that you won't need to send a full user-to-user matrix. Again, please look to the detailed documentation for further information. And our final scenario is the MMO scenario, where we have many users connected to the same game who may also be part of a smaller team within the game world. Since we can have more than 100 users in the world at once, we'll need to use the large sessions when using MPSD. We'll also need to maintain a separate session to be used for joins and invites for the smaller groupings. MPA, however, would use the same service-to-service calling pattern that we just saw. A large MPSD session is one that is used for sessions with more than 100 users. It is denoted by the session property large true, bolded there on the slide. These sessions function differently than regular sessions. Operations to large sessions are always carried out as a single user. As a result, service-to-service calls to large sessions must only include a single user in the on behalf of users header. Adding and removing users must be performed through individual calls for each user. So you do lose the benefit of doing multiple updates in a single call. Large sessions do not provide access to the full member list either. Only the data for the user specified in the call will be returned. Title services would therefore need to track the user information for members of large sessions in their own logic when using MPSD to support the XR requirements. Large sessions also do not update the recent player list automatically. Instead, players are added directly to recent players list through encounters and groups. And you can see an example of that on the right side of the slide. In order for recent players to update correctly, these encounter properties must be written to all session members in under 30 seconds. Now, this set of encounters is known as a point-in-time property, so it's immediately consumed and won't be visible in any responses. Now, as we just saw, there's a lot of extra work needed to support large numbers of users with MPSD. However, with MPA, there's no difference from the previous samples. You'll make the same calls to update encounter information. And this brings us to the end of the presentation. And we can answer one final question, which is, how do I choose? Well, the choice of which service simply comes down to whether you intend to use MPSD for all your multiplayer services or not. If you don't need to use MPSD, we strongly recommend using MPA to satisfy the Xbox Live requirements. Thank you again for taking the time to watch this presentation. I hope it has provided enough information to make informed decisions and to give you an idea of what's needed to satisfy the Xbox Live integration requirements using MPA and MPSD. Have a great day.